Today we are going to review for a quiz. Now the quiz is going to be over section 8-2, day 1, 8-2, day 2, and 8-3, day 1. And the topics that the quiz is going to be over simplifying rational expressions. It's going to be over multiplication and division of rational expression. And it's going to be over finding the least common multiple. Alright, now what we're going to do today is I want you to work through each of these quiz review questions. There's 6 of them. Now, on each one, I want you to pause the video, do the question on a separate sheet of paper, and then after that, after each problem, we're going to work through it together. Okay, so in the first problem, it says simplify that rational expression, identify any R values that will make the expression undefined. Okay, so pause me and work through it, and then we'll look at it together. Okay, go ahead and pause. Alright, so going through this first question here, let's see what we're doing here. So with the first question here, the first thing I want to do is I'm going to set up my little organizer like I normally did, like I showed you in class. So we have my numerator here, we have my denominator here, we put a little squiggly down the center to separate it, and I'm going to factor out each one of these. So here's the first one, there's the top, here's the bottom. Now in the top I see I can factor out a 2r, and I'm left with an r minus a 2 inside. Alright, over on the denominator here I can't factor out anything. So let's go ahead and put it back in fractional form. So I have 2r times r minus 2 all over r minus 2. Now let's look to see if there's anything that'll divide out. And yes, you can see here by looking at this one that I do have an r minus 2 right there, and I have an r minus 2 right there, so we can divide out. So this will divide out with this, and that leaves me with an answer of just plain 2r. Now, we have to find out where it'll make it, where the rational expression is undefined. I do that by taking a look at my denominator. So we're going to look at the denominator and ask ourselves, where would this denominator be undefined? So I can see that it's going to be undefined by setting r minus 2 equals to a 0 and solving it. So we're going to add 2 to both sides, and I get r equals a 2. That tells me that if I plug in a 2 in for my denominator, let's look back at the original question. If I plug in a 2 in for my original equation, right up here, I would get 0 in the denominator. I can't have 0 in the denominator, so therefore I'm going to put r cannot equal a 2. And that is our answer. On the second question, I want you to look at the numerator and denominator. We need to make sure each of those trinomials are in standard form. In other words, they're in descending order. So let's take a look at each of these. If I look at the top one here, is it in descending order? I see 24 minus x squared. Oops, we can stop right there. No, it is not in descending order, because I need to have this one first, I need to have this one second, and this one third. So remember to always do that. Then it says identify any values of x which would cause it to be undefined. Okay, so now that you know what to do, go ahead and pause the video and work through the question. Now that you've had a second or two to work through this question, let's go ahead and work it out. So let's see, I have my numerator here, my denominator here. Oops, cannot spell denominator here today. So denominator there, put a little squiggly down there. Okay, so now let's write this down in descending order. So I have negative x to the second plus a 2x plus a 24. Now for starters, I'm going to factor out a negative 1, giving us x squared minus 2x minus 24. Now I'm going to factor this, and I need to find out what factors of negative 24 will give me a negative 2, and that would be negative 6 times 4. So my factors here are going to be x minus 6, x plus a 4, and I'm going to bring this negative 1 down there just like that. Okay, now the denominator part, so we have x squared minus x minus 30, and I need to figure what factors of 30 will give me a negative 1. So that's going to be negative 6 times a 5. So my factors there are going to be x minus 6 and then x plus a 5. Okay, let's put this back in fractional form. So I have negative 1 times x minus 6, x plus 4 on the top. And on the bottom, I have x minus 6 and an x plus a 5. All right, now let's look to see if there's anything that's going to divide out. Well, what do I see here? Well, I see an x minus 6 on top and an x minus 6 on the bottom. So those two will divide out. And do I see anything else on top? I see a negative 1 on the top. Do I see a negative 1 on the bottom? No, I don't. I see an x plus 4 on the top and an x plus 5 on the bottom. Now, one area where students make mistakes, sometimes they'll say, oh, there's an x and there's an x, so let's divide those out. You cannot do that because this isn't just x, it is x plus 4. And you have to have another x plus 4 down here, and you don't. So that tells us at this point that it is all divided out, and I'm left with negative 1 times the quantity, x plus 4, all over x plus a 5. All right, now we needed to find out what would cause it to be undefined. So go back to the division here, the rational expression before we simplified it. You see I have an x minus 6 and an x plus 5. We're going to set both of those equal to 0 and solve. So let's see here. Let me change pen colors, maybe get a blue here now. So let's set x minus 6 equals to 0. Going to add a 6 to both sides, and I get x is equal to a 6. All right, now I'm going to set an x plus a 5 equal to 0, and I'm going to subtract 5 to both sides, and I get x is equal to negative 5. All right, now these are the two things. Notice here, if I were to take 6 here and plug it into the original up here, it would give me 0 in the bottom. If I were to take negative 5 and plug it in up here, it would give me 0 in the denominator as well. So right here we need to say, comma, x is not equal to a 6, and x is not equal to a negative 5. And there's our final answer. For problem number 3, it is multiplication. Now notice here you have a monomial up here, just a plain old monomial, divided by a monomial. Over here you have a monomial divided by a monomial. So I need to divide those out. Now, there's two ways you could actually do this. And you could multiply it all together and then divide out, or you could try to divide some of these, like the, let's see, the y here with the y down there, and the z there with the z over here first, and then multiply together. So it's up to you what you want to do. My choice, if it were me, I would probably multiply it all together, then divide out. I have found that students tend to understand that better doing it that way, but it's up to you. Now, I want to point one more thing out to you here. It says assume that everything is defined. That means you do not need to set any of the variables in the denominator equal to 0. So you can just simplify it. Okay, pause it, and then we'll work through it here in a minute or two when you have it done. Okay, now that you've worked through this question, let's go ahead and work through it together. So I am going to go ahead and kind of multiply everything together. I don't think I'm going to multiply the numbers, though. I'm just going to go 8 times 9, and then I see x to the 4th times x to the 1st, which is x to the 5th. I see y to the 2nd times y to the 2nd, which is y to the 4th, and then I have a z to the 6th. And on the bottom, I have a 3 times a 4, then I have a y to the 4th, and then I'm going to put a z to the 3rd. Now maybe you're asking me, how come you use the community property and rearrange the y and z? Because look up in the numerator. In the numerator it says x, y, z, so I put it in that same order down below. Do you have to do that? No. But I just did because it makes it a little bit easier to see sometimes. Okay, so looking at this one, first of all, I see that 3 goes into there once, 3 goes into 9 3 times. 4 goes into 4 once, 4 goes into 8 twice. Okay, so now you can see why I didn't multiply the two numbers together. Now I see I have a y to the fourth on top, so this divides out with this. I have a z to the third, that divides into z to the sixth, leaving you with 3 of them. Alright, so now we're ready to multiply everything back together. So at the top I get a 6, then I have an x to the fifth, and a z to the third, and on the bottom, let's look here. It looks like everything's divided out. So I can just be done. On this question here, notice this time it's not multiplication, it's division. That means we need to use our KFC. That means we're going to keep this the same, we're going to flip this part of it, and we're going to change that from division to multiplication. Alright, so let's go ahead and do that. So that gives me 3x to the 9 divided by 2x to the 8th y. Keep that the same. I'm going to flip the second piece over, so it's going to be 2y to the 6th over a 9, and I'm going to change it from division to multiplication. Okay, now we're going to do the same as what I did on the previous problem. So I'm going to rearrange I'm going to rearrange it and push it all together. Now again, I'm not going to multiply the 3 and the 2 together. I'm just going to go 3 times 2, x to the 9, y to the 6th, and on the bottom here I have 2 times 9, I have x to the 8 and a y. Okay, so it didn't turn out that I couldn't multiply anything together. So now let's see. This 2 divides out with that 2. This 3 goes into there once, goes into here 3 times. 8 to the x power divides out with all but one of those. This y divides out with that y to the 6th, leaving me 5 of those. Now, from here, let's see. What do I have left on top? So let's observe this. This is a 1. This is a 1. This is x to the first, and that's y to the 5th. So I'm going to put x, y to the 5th on the top. And on the bottom, let's see, what do I have left? The 2 has gone to a 1. This is a 3. This is a 1. This is a 1. Okay, so it looks like I just have 3 left in the denominator. So, my final answer, right there. In looking at this question, notice this one's a little bit different. If you look here, it's not an expression, it's an equation because it's equal to a -2. Now, remember from the previous sessions, I had you cover up the second half and just simplify it just like what we did in the first couple problems. So I'm going to write numerator here and my denominator there. And we're going to put my numerator here and we're going to factor that numerator and the x minus 3 denominator. Okay, so now the factors of 15. Now remember here this. Remember when my constant is positive, I look to my linear term and that will be the signs of both of my factors of 15. So that means my factors are going to be -5 times -3. Or you could have put -3 and -5. Now when I factor that, my factors are going to be x minus a 5, x minus a 3, and now looking at my denominator, notice here I cannot factor that. It's already factored down its prime already. So let's go ahead and let's put the numerator back on top of my rational expression and put my denominator down here. And now we're going to look to see. Alright, look up here. Is there anything up here that'll divide out with anything down there? And yes, I can see that I have an x minus 3 common to the top and the bottom, so those will divide out. And that leaves me with just an x minus a 5 in the top, and there's only a 1 in the bottom, and I don't need to write that 1 in the bottom. Now it's time to uncover the -2, and I'm going to bring this -2 right here down. So that's going to be equal to a -2. And now I'm going to solve this. In solving for it, we add a 5 to both sides. and I get an x equals a 3. Okay, so it looks like at this point that my answer is x equals 3. Or is it? Remember, you always have to plug your answer right here back into my original. And notice when I plug it in right there, I get 3 minus 3 is 0. That is undefined. That tells me this is an extraneous solution, and my answer is no solution, or the empty set. For question number 5, we're asking you to find the least common multiple for this expression and this expression. Okay, go ahead and pause it, and we'll talk about it here when you're done. Now that you've worked through this, first thing we want to do is we needed to factor your 4 and your 10, and then write down each of the factors. Okay, so notice that the 4 is 2 squared. And then I have an x plus a 7 to the 4th, and I have an x minus a 2 to the 8. For the second one, let's see, 10 is 2 times 5, and then I have an x plus a 7 to the 5th, and then I have an x minus 2 to the 5th. Secondly, I want to write down each of the factors. So let's see, I have a 2, I have an x plus 7, an x minus 2, and a 5. So those are all my different factors. So I'm going to put a 2, and an x plus 7, and an x minus 2, and let's see, I have a 5 as well. You know what, I'm going to put that out front because I kind of like the numbers out front. Okay, so I have those factors here. So now let's go ahead and let's find the LCM. So for the LCM is going to equal to, and I'm going to take each of the factors. So let's start with the 2, and let's observe here. Up here I had 2 2's here, and I had 1 2 there, and I want the most of each factor, so I'm going to take 2. Now I'm going to put multiplication because we multiply each of these together. My second factor was a 5. And let's see what we have. Here, no 5s. Here I had 1 5. So the greatest number between no 5s and 1 5 is 1 5. Okay, next I'm going to take x plus a 7. And looking here, I have 4 here. Over here I have 5. So the largest number between 4 and 5 of them is 5. So we're going to take 5. And lastly, the last factor is x minus 2. And let's see, I'm going to look here, and I see I have 8 x minus 2's. I see 5 x minus 2's, so the largest number between 8 and 5 is 8 of them. So now, remember here, it's multiplication between everything, just so you know. So, what is my least common multiple? Well, I can multiply it all together. So let's see, I have 2 squared is 4, 4 times 5 is 20, so it looks like it's going to be 20, x plus a 7 raised to the 5th, x minus 2 raised to the 8. And that is my LCM. Now we have reviewed for each of these questions. So what I want you to do now, I have 6 more questions here. I want you to pause the video, and I want you to practice some of these. So go ahead and look at them, and on a separate sheet of paper, work through each of these questions for your review. Now, if you would like, after doing each question, after working through all 6 of these, later in the video, I've shown the answer to each one of these. But the first thing that I want you to do is work through these, see how you do, and then play the rest of the video to check your answers. Now that you've finished 1 through 6, let's go ahead and check your answers now. So, looking here, I see question number 1. Here's your answer for question number 1, and here's an explanation of how you did it. For number 2, here again is your answer right here. And right over here is the explanation of how you did it, with where it's going to be undefined. Alright, so I'm going to let you go through the rest of the video checking your answers. Here is question 3 answer and your description. Here's the answer to number 4. And if you missed it, this is how you can study this for a second and pause it to see how it was done. And for number 5, there is no solution. And this is why there is no solution. So you can pause the video here and look to see how we did this question. And here is number 6. Here's your answer to number 6. That was your LCM. And this is how we found the LCM, right through here. You can pause this video and look at this more carefully. Now that you've gone through and you reviewed and we've talked about each one of these questions for your review, for your quiz, when you come to class next time, we're going to probably just take a few minutes for questions, grade the homework, and we're going to get right into the quiz. So if you have struggled with any of these, please go back to your textbook and just practice some problems out of the textbook. All right, that's it for the day. Good luck on your quiz next class period.